It is quite an honor. I get to introduce my colleague, Charles Turner. He'll be talking about Python for climate science, using Intake to provide easy access to climate model data. Charles is a research software engineer at ACCESS-NRI, which is Australia's climate simulator, where he works in the model evaluation and diagnostics team, helping make it easier to access and analyze climate data. He previously worked in air quality, where he produced tools to analyze air pollution data, and has a PhD in oceanography.
Yeah, I'm Charles. I'm going to talk today about how we use Intake at ACCESS-NRI to provide easy access to climate model data. This is actually not going to be super technical. The talk's largely going to be about marketing and user experience, because that's kind of what we focus on, or how I like to think about it. So let's go right into it. Does anyone know who this is? No, I thought, I see one person nodding. This is a guy called Alex Hormozi. When I Googled him, it said that he was a serial investor, entrepreneur, and internet personality. And if you're wondering why I've started my talk with a picture of an internet personality, the reason is I was listening to something the other day and I heard this fantastic aphorism, the pain is the pitch. And I think this really drills down into the heart of what Intake's good at. So if you want to solve a problem, basically you need to just really understand what it is that's hurting people about it, right? Because if you don't get that right, you're not going to be able to provide the right solution. And so this is what I'm going to focus on throughout the talk. So like, what is the problem that we're trying to solve, right? If you go to the Intake repo, at the very top, there will be Intake taking the pain out of data access and distribution. I promise I didn't contrive this just so that it all fitted together, like it was just a pure coincidence that I came across it at the time. So yeah, the problem we're trying to solve is just this like chronic nightmare of how do I get my hands on climate model data, right? And it's just never ending. I just want to also address Australia is a very different country to the US. Australia has, by my count, 6 cities. We have 2 major supercomputing centres, and nearly everything climate-related happens on Gadi in Canberra, which is in that kind of little dashed ACT area. So this is kind of all HPC-tailored stuff. It's not very cloudy, and it's static, filey stuff. Anyway, let's get into it. So the question I'm going to talk about today is what happens if I don't know where my data is, right? On the left here, I've got what I kind of consider to be the life cycle of how we do science. So we think of an experiment, find some data, analyze it, evaluate it. How do I understand this? And then maybe we need more data and we go round until we kind of have a complete loop, and then we go and run a paper, right? So in my instance, during my PhD, we were working with observational temperature and carbon data in the North Atlantic. And we realized one day that we kind of needed some model data in order to drill apart, tease apart the different kinds of carbon in the ocean and understand what was actually going on. One of my supervisors, Kevin, said, really luckily I had a previous PhD student, Matt, that actually did some global simulations that contained all these different types of carbon. Go and ask him, I'm sure he'd be happy to let you use the data. Matt was no longer at the university. Matt had moved to Reading. We were in Southampton. And so Kevin said, go down the corridor, go talk to Andy. Andy was involved with the modeling side of things. He might be able to point you towards the data. And here's Matt's email address. So I went down the corridor. I talked to Andy. Andy says, yeah, I'm pretty sure I know where this is. Come back in a couple of hours and I'll see if I can get you the data. I go back to my office. I send Matt an email. I make a couple of cups of tea because we're English. Then go back to see Andy. Andy says, I'm really sorry. It's all on tape now. Come back in a couple of weeks, and hopefully I'll have got it back off tape for you, right? I'm sure this is an experience everyone's had if they've worked trying to use other people's data in the past. What then happens is, so I email Matt. Matt replies, yeah, sure, happy to use the data. Here's a MATLAB script that I wrote a couple of years ago that I used to extract everything. So over the next couple of weeks, I try and reverse engineer Matt's MATLAB script. Andrew eventually sends me, this is where the data is, and now I can start working with it, right? At which point I discover all the paths have changed, I need to rewrite the script, and things are structured differently, and this goes on for weeks, right? So this is literally just this find some data part of the diagram. And the real issue here is that finding that data often has little to no scientific value, but it's super time intensive. Sometimes it is like scientifically valuable. Sometimes you come across a blog post that's written in Romanian and Google's translated it for you and you find something really useful you never would have otherwise. But often it's just a complete time sink. And at the end of all that process, you wind up with something that looks like this. I've stolen this from the Intake documentation, so I put a meme in to credit it properly. But this is kind of a typical data science-y workflow. And so at the end of all this process, we import some packages, we set a couple of paths, and then we do some generic pandas-y looking data analysis, right? And this 3-week process of trying to find where all the data was finally corresponds to this one line. So it's effectively wasted effort, other than the fact that we needed to do it. So like, the question is, can we do better? In practice, what this looked like for me, so I was given a path, go and find that. Okay, now, all right, we need to go and inspect what's in there, right? So like, if you're a first-year PhD student that's never used the command line before either, right? So now you've got to go and use Stack Overflow or whatever to find out how to do this. So, okay, tree-do that. Okay, so we've got output, 976, 77, 78. I was an oceanographer, so probably wanted to look at the ocean one. So we CD into the ocean, one of the ocean folders. And we say, oh, there's all these things that .nc, what's that? And so someone goes and tells you, oh, you know what you should do? You should use ncdump to look at those. So you ncdump the file, and it spits out a million lines of numbers, and you panic. Eventually, you work out ncdump-h is what you need. And then eventually, you go, oh, okay, so this has got these variables in it. And after this whole process, eventually, if you're writing Python, you wind up with something like this, right? So you import xarray, then you give it a big list of paths. You might have globbed this instead. I just kind of copied and pasted them out. And then finally, you open the data set and you start doing your analysis, right? In this whole process, like, you've had to choose that you're using xarray. There's no particular reason that, obviously xarray is very popular, but you might have used Iris or just plain old NetCDF4. And it's, yeah, you just need to work out all these paths manually, right? It's inefficient. So let's talk about data catalogs, right? What are data catalogs? This thing here is the Argos catalog. Anyone from the UK will recognize this. Argos were a chain of shops which didn't have any aisles or anything. You went in there, there were these kind of toadstool tables, they had catalogs on there, cleverly color-coded. And so what you would do is you basically open the catalog, flick through to what you wanted, there'd be a little number, yeah, I want that, you write it on your little slip that they gave you, you take it to the till, and then someone would go and find your lime green kettle, or whatever it was that you wanted, right? You wouldn't have to go through the shop yourself, it would be brought to you. Data catalogs work much the same way, so it's kind of like a centrally curated and managed store of data. It's easy to search, so you just know what you want, not where you want. Argos would have failed if it told you where it was and then you went round there. It would be no different to a regular shop at that point, really. And it unifies discovery and access, right? So once you've searched the catalog for what you're looking for, the catalog then goes and brings it to you. You don't have to go and get it yourself. So let's start talking about Intake-ESM and how Intake fits into this whole problem, right? So Intake itself has loads of clever metaprogramming features. We don't use most of them in our workflow, but one really crucial thing is it has this really clever module-level get-atter in its init. So if you do intake.open_something, it basically goes and looks in its registry of drivers, and if it finds one that matches, it will load it with that. Intake-ESM then has this ESM data store class, which gets registered in that registry. And the net result of that is that if you call intake.openESM data store, you get this data store out, right? So in this instance, I think this is the Australian CMIP6 data. So there's like just over 1 million files. And you can see it's split up by lots of different things, right? And at this point, we can search for it all. So maybe I was interested in ocean data or whatever, right? So we can go with that. So when we kind of tail this all together, so we say intake, open our ESM data store. I think this is the same one. And then search. So in this instance, if you speak these sort of CMIP codes, you'll recognize all this. But this basically says, give me surface ocean temperature on a monthly frequency for historical data. And then at the end of all that, you just call to Dask, and it spits out an xarray data frame for you, right? So this process of 3 weeks faffing around trying to figure out where stuff is and what's the correct way to glob stuff and how to open it's now been crunched down to, you just need to know where the catalog is and how to interact with that, right? Much, much quicker. The question we might then want to answer is, like, have we actually made our users' lives any better? And I know this might sound a bit facetious, but I'm being serious here, right? They no longer need to know where their data is, right? So that's unequivocally a good thing. Someone else can manage it for them. One person can do it and manage it for an entire country is basically how we're doing things in Australia now. They no longer need to know how to open their data, so the choice of whether they use Xarray or Iris or NetCDF or MATLAB or Julia or R or whatever you want to do, that's been made for you. Although obviously the latter languages would be a completely different ecosystem. But you do need to now know where the catalog is, right? So previously you needed to know where the data was, now you need to know where the catalog is. So what we've actually done is we've successfully replaced a previous problem with a new problem. As anyone who's ever driven an old car will attest, we're really good at ignoring problems that we've had for a long time, and we're really sensitive to new problems. So this is not necessarily the kind of solution that users would be happy about because their workflow changes and they still need to know where the damn catalog is. Intake has more tricks up its sleeve that can alleviate this. So back to its and it, there's this imports dictionary, and it also has some logic related to that in the get-atter. We maintain a separate package called ACCESS-NRI Intake Catalog that manages the distribution of all our data. And in that's pyproject.toml, it has this entry point. Entry points aren't just used for console scripts, you can also use them for plugins. That's kind of the basis of how Intake all works. And basically what that does is maps to this bit of code that when you call now intake.cat.access-NRI through that entry point, it basically opens the data object that's generated in that file. And so the net result of all this is we just tell our users import intake and then just intake.cat.access-NRI and you get the catalog. And from there, they can just begin to interact with this and pull all their data out. So let's go through our solution stack. This is a really hideously complicated and badly formatted slide, I'm sorry. We kind of got two sides going on, build time and runtime. I'm going to talk about runtime first because it's much simpler, and then I'll move over to build time. So at runtime, we just have this kind of big oval intake data frame catalog. We have an intake data frame catalog. I'll talk about that in a sec. And that wraps a bunch of ESM data stores, which are kind of the object type of intake ESM. The reason I've colored them both the same is because Doogie Squire, who wrote intake data frame catalog and kind of set up most of this stuff originally, he basically pilfered most of the code base of intake ESM and then adapted that to make the intake data frame catalog. This had two really important benefits. Number one is it was much quicker and easier for Doogie to do that. Number two, and probably more importantly, is that users don't even know that they're separate packages. They look more or less the same. They work pretty much exactly the same. And so there's this one really nice, coherent, harmonious interface. So intake sits at the bottom. Then we load an intake data frame catalog, and then that gives us an intake ESM data store back. And then at that point, we can just load our Xarray data sets from it. Build time gets quite a bit more complicated. So we have our ACCESS-NRI intake catalog. That contains a bunch of YAML files that specify paths and builders and configuration and such like. That then creates an empty intake data frame catalog. An intake data frame catalog is what we can think of as a meta catalog, so it's a catalog of catalogs. And that then gets populated. So intake ESM has this kind of sister package, ECG tools. And that contains a bunch of like a base builder class that you can subclass in order to say this model outputs data in this format. So just go and traverse the file system and kind of work out what's in there. So we use these ECG tools builders. We populate our meta catalog with ESM data stores. Those then go back into our intake data frame catalog, and the way it percolates up at the very end is that the ACCESS-NRI intake catalog provides access to this meta catalog without ever actually having to need to be imported. So I've just left this slide on here just in case I jumble that up because it's quite complicated. So we have builders. They create ESM data stores, which subclass ECG tools to do so. They basically traverse the file system specified in all our YAML files, open up the NetCDF files that contain the data, extract the metadata, and then just cache that effectively. We have translators, so we're not the only ones in Australia building intake ESM data stores. There's NCI too, who also operate on Getty. They kind of run the computer, actually. And so their ESM data stores don't necessarily have the same structure as ours. And so we have these translators that just provide a compatibility layer between the two so that users can search them in our data frame catalog. These can and do break. I'll get into that later. We push as much of the complexity as we can to build time, so we just want the users to just import intake and open the catalog, and they're away to the races. Minimizing runtime work's obviously really important. So the reason that we have this intake data frame catalog is so that we can nest the individual ESM data stores. Trying to open the CMIP6 data store was taking about 4 seconds a couple of months ago. This is an issue because people just think it's broken. Like if you don't have a loading bar and something takes 4 seconds to load, people just go, oh, there must be something wrong, I've done something wrong, it's broken, and they just hit Control-C or stop the notebook cell, and then they go and ask someone, and then they come back and they go, no, it just takes a while, you just got to wait. And this is another source of wasting time. And making it just work, really, really important, right? Like we're trying to build a data access solution for people, and so we need to be really careful that we don't make them learn a new thing. We want it to just work for them. And I just put this in. This is the resource usage. So it takes about 2.5 hours to build the catalog if we throw 48 CPUs and 192 gigabytes of memory at it. So we're basically pushing all this work to build time, and then the users find it easy to work, easy to open the data and work with. So putting it all together, this is what it looks like. So our users import intake. They then call intake.cat.access-NRI. They haven't imported our ACCESS-NRI intake package at any point here. And you can see now there's a bunch of different data sources in there. So about 3,000 rows, 120 sources. And then, so you can just open one of these. So I've just stolen this from a previous slide because I didn't have a picture to hand. And so finally, the whole process from importing intake to getting the whole thing looks like this now. So I've just selected the very first experiment in the catalog because I'm really inventive. And then I've just said I want ocean temperature on a monthly basis. And then at the end of all that, we just call to Dask. We get a data set out. And from there, we're ready to go. We can analyze it, play with it, do whatever we want. So yeah, this is fantastic at this point, right? Okay, so I've talked the whole time about the issue of what if I don't know where my data is, right? But that's kind of a questionable assumption. Someone is running the climate models, unless we've got to the point where vibe coding is now how climate modeling is being done too. There's going to be someone that knows where that data is, and they're going to either want to use the old way now or use the new way. And if they want to use the new way, which is we're going to use an intake catalog to do this, if we don't provide them a tool that builds the catalog for them, they're now going to have to learn how to build an intake catalog too, right? So it's really crucial at this point that we just don't solve our self-defined proxy problem of what if I don't know where my data is. We need to revisit that. And this is all about making tool adoption easy, right? If you give someone, here's a new way of doing something that's different to the old way of doing it, and they've still got to learn both of them, they're just going to use the old way of doing it for everything. So it's crucial that we make things seamless. And so what we did is we just built this build ESM data store tool. What this does basically is it kind of subclasses that build process, or it's a subset of that build process. So you basically just say, I want to use this builder, this is the model I ran, this is the directory the outputs are in, and this is where I want to put my catalog, build it for me. And guys are also now working on actually integrating this into the model running tool, so when you run the model, you get a catalog at the end of it as part of the whole process. And going back to my point from a slide or two ago about people just think things are broken if there's no output, if you can't make things perceptually instant, spitting out some output is really, really important, right? Because people know that something's happening. Transport for London, when they were trying to figure out if they could improve customer satisfaction on the tubes, someone floated the idea of just running more tubes, which would have been really, really, really expensive, right? And someone else said, why don't we just put screens above the station that tell them how long they're going to have to wait for the next tube? And I think they found that it was the most effective money they ever spent in terms of customer satisfaction, because it's much worse waiting for something when you don't know when it's going to happen than when you know it is, right? It's part of why Uber's so successful, because you can see when the car's coming. Right, let's get into sort of training and supporting users. So there's a thing called COSMA. It's the Consortium for Ocean and Sea Ice Modeling in Australia, I believe. COSMA have this fantastic resource called the COSMA, what's going on there? There we go. Fantastic resource called the COSMA Cookbook. And this is basically, maybe we're going slide 3 for the rest of the talk.
Not going to be helpful.
Is that, if we, oh, sorry. I could just stick it straight into the HDMI maybe?
Do you have an HDMI?
Yeah. Oh, God. Fingers crossed that works. Ah, yeah, that's back. Right, play from current slide. Is that, oh, that's strange. Why has it done that? I can see it on my thing, but it's just showing my screensaver. Yeah, maybe.
Can you just drag this?
Yeah. What the hell is going on? Let's just try plugging it back in now. Yeah. Oh, something's happening.
Looks promising.
Okay, right, cool. I've got no idea how much time we left, so I might have to zip through these a little bit quickly. 5 minutes? Cool. Customer Cookbook's a brilliant resource, so it basically has a bunch of these notebooks that just run users through a bunch of tools that they, a bunch of techniques that they might want to use. So like, how do I get the overturning circulation in the Atlantic, or sea ice formation around Antarctica? I don't know if anyone ever looked this thing up. I found it out separately, but there's this thing called diataxis. This was, I think, invented by like the Greek Orthodox Church. I think they've been working on this like theory of pedagogy for like 1,500 years or something. And they kind of have these 4 pillars. So tutorials, how-to guides, explanation, and reference. The Customer Cookbook like hits all 4 of these really well, right? And so this is just like a sample notebook in here. So you can see we've got, we tell them what we're doing, we tell them why we're doing it, we give an example of it, and then there's some exposition about how the tool itself works underneath there. And the Customer Cookbook is organized into, I changed recently, I think it's like entrees, starters, mains, puddings, in order of basically increasing difficulty, right? So if you're like a first-year PhD student who's never used any of these tools before, you can just clone this repo, get on the HPC, and just start running through them and gradually build yourself up to doing the more complicated analyses that you might want to do. So this is kind of like a brilliant resource in terms of training users. At ACCESS-NRI, we also have a discourse forum where we provide active and vocal support for our users. So we kind of have this guarantee that we provide that if there's a tool that we support and you have a problem with it and you come to us, we will assign someone to it, to you, and they will get it fixed for you or help you fix it. And that's kind of why I've italicized making users feel supported here. Like I'm not saying like it's, we need to mollycoddle people, but like it's building that trust between our user base and us. This is not an official policy yet, I don't think, but I keep saying it in public, so hopefully it will become that at some point. But like, there are no stupid questions, there are only bad documentation. The person that wrote the software is obviously the most familiar with it, and things are obvious to them that aren't obvious to anyone else. And so we have, this is just a post of mine that I picked. So this was not actually released at the time, so I had to help a user install it from Git. But anyone who's read this whilst I've been waffling will notice that I hadn't, the machine wasn't up at the time, so I couldn't check whether this was right. This was basically a loading bar, right? Loading bars are great. Like, if you can't make things instant, you should use loading bars. Okay, what about when things go wrong? So because this is like a file-based indexing system, like things can and do move, and then the references go stale and it's not there. Basically, our solution to this is just to maintain trust with our users. Like, if they believe that they ask us to fix it and we fix it quickly, they're more likely to come to us and point out things are wrong rather than silently abandoning our software and just globbing file lists as they used to. And we have cron jobs and stuff that test that these things are still valid. So I'm just going to wrap it up here. So I haven't talked about SQL at all in this talk, which would traditionally be the way of indexing loads of different stuff. We did previously have a solution that was based on a SQLite database. I don't want to bash SQL. It's a really powerful tool, but it's not the only hammer in the toolbox if you're trying to index a bunch of stuff. Intake is really, really incredibly powerful. I've really only scratched the surface here. V2 was released a year or 2 ago, I think, and we haven't used any of the features in it yet. And it can do heaps of stuff. training and support, they're as important as the tools that you produce, if not more. The best way to kill a bad product is a good marketing campaign. And like, if you want people to use stuff, you need to build a good thing, but then you need to make them want to use it. And building trust between you and your users is like really, really crucial for that. And finally, if in doubt, just give users some sugar. So the next talk, I think, is about rewriting things in polars. I recently rewrote the back end of Intake-ESM to load stuff with polars rather than pandas. And those 4-second loads that were making people think things were broken, they're now 20 millisecond loads. So if in doubt, give people interactive widgets, make things faster, like, they'll love it. Anyway, thank you very much. I'd just like to acknowledge our funding, which is NCRIS. I think that's the main source of our funding, right, Paige? Yeah. So, yeah, thank you very much. Happy for questions. Do you want me to just stand out of the way?
Hello? Oh, it works. No, you stay there. Thanks, Charles. That was awesome. Thanks for moving on after the little technical glitch. I don't see any questions yet in the Slack, so if you have any questions, please do ask them there. I will read them out. We have a couple minutes for some questions. I think I'll kick one off while we wait. So you mostly talked about helping people, helping the scientists like access the data. What about like the discoverability? So what if they don't know what data set they want, but they know, they know the variable they want and that kind of thing? Yeah,
right. This is like a huge thing too, right? So you don't need to know that you want date, like you don't need to know particularly that I want this experiment or I want this, right? So when you import this total catalog, you could just say maybe I want to search for all the ocean data, right? So I could say .search realm equals ocean, and it would give me all the experiments that contain ocean data. Or maybe I want, I don't know, sea ice, which would be like AISM or something. So it's also a way of finding all the experiments that have data containing variables or frequencies or forcings or anything that you're interested in. So as well as finding the data that you want, it also helps you find the data that you didn't know you wanted, right? Which is, it solves a much bigger problem than just that core problem too.
Yeah, cool, thanks. We have a couple questions here. Apologies if I get the pronunciation wrong. We have a question from Gunnar Godal. Says, could you expand on the comments you made about helping users at different experience levels?
Yeah. So I guess this would go to like the customer cookbook level stuff. So it's really easy when you're an expert in something, and if you're maintaining the package, you are kind of by definition an expert in something, to just assume that everyone understands how it works. It's just kind of the way that the human brain seems to work. And so it's really crucial to have, I think worked examples, right? Like every maths textbook has worked examples, and it goes the whole way from 1 + 1 = 2 to trigonometry and differentiation and yada yada. And so I think like having this archive of like, here's a simple example, here's a slightly more complicated example, and like if you don't understand any of these, come and ask us, and we promise we will definitely help you. I think that's really, really crucial in onboarding people. It's about having steps, but also like a guarantee to someone that if those steps are too big, someone's going to come and lead you through them. Yeah, okay, so that support, kind of ongoing support is important. Yeah. All right, we have a few more questions. Do you track usage metrics for the catalog? If so, how? Yeah, we do. This is one of the more interesting pieces of code I wrote. So I wrote an IPython plugin that contains an AST parser that listens for certain types of class and function calls. And if it detects those, it will pass off a function name, args, quargs, and some other associated metadata. And then we just have a Django server where we collate all that. And that's really helpful because it lets us see what experiments people are using, what are they searching for, how are they searching for stuff. Come and talk to me afterwards about that because I'm super excited about that. It's one of the more interesting pieces of code I've ever written. Yeah, cool. I didn't mention that was from Max Grover. Oh. We are, maybe one more question, and then we'll have to move on. All right, you'll have to go into Slack after. There are a couple more. How have you encouraged all the scientists to load in?
How have you encouraged all the scientists to load into the catalog, or did your team have to organize all of the data? This is from David Flasterstein.
I actually don't know the answer to that. So originally, Doogie was involved heavily with this. Doogie wrote most of the ACCESS-NRI intake catalog package. By the time that I joined the team, like the Ocean community were pretty on board with this, and so they would come to us and they'd say, "I've done this experiment. Please, can it be added to the catalog?" And then we go back and say, "Can you give us this metadata?" Yada yada yada. And so we have this really good relationship now with Cosima, the Ocean modeling community, where they say, "We'd like to add this to the catalog. Please, can you help me with that?" And I think the more that happens as well, the easier it becomes, because it becomes a default of, someone's got lots of experiences of, "Oh yeah, I asked them to add this and they were really helpful with it." So that's really good.
Yeah, I can actually add to that because I'm the training team lead at the same place, and we are planning some training sessions to help scientists to add their data to the intake catalog. We haven't done that yet because it's kind of next on the horizon after all the work Charles has been doing.